Okay, let's simplify some radical expressions with exponents. Here we remember that if we have the square root of something squared, x squared in this case, we have two x's, so the square root of x squared is x. Now the key in knowing in doing these is in finding and knowing perfect squares of variables, which are different from perfect squares of regular whole numbers. A perfect square with a variable are just variables with even exponents. So x squared, x to the fourth, x to the eighth, x to the 12th, x to the 22nd. Those would all be perfect squares with regard to variables. So if we look at this one, for example, we have x to the fourth. It is an even exponent. So that means we are going to have 4 y's. And remember, we're looking for pairs. So here we have a pair of y's. And here we have a pair of y's. So with this one, we can take one y out from under the radical. And here we can take another y out from under the radical. We have 2 y's then, which means we end up with y times y, which is y squared. So the square root of y to the fourth is y squared. Now here we have m to the fifth. That means we have 5 m's. And again, we're looking for pairs of m's. So we can have this pair, and we can look at this pair, which means we take out 1 m for this pair, and that's this one. We take out 1 m for this pair, and that is this one. And we are left with 1 m inside. So we have 2 m's out, 1 m in, which means our answer is m squared times the square root of m. Now let's talk for a moment about cube roots. That simply means that something to the cube root of something cubed is going to be itself. So the cube root of x cubed means there are 3 x's, and the answer to that is x. And the key here is in knowing and finding perfect cubes of variables, or 3's. So perfect cubes are any variables with the exponents that are multiples of 3. Whoops, I made a mistake here, because this would be x to the third, this would be x to the 6th, this might be x to the 12th. Those would all be perfect cubes. So here we have the cube root of m to the 6th. That means we have 6 m's, and it's the cube root, so we are looking for 3. So here we have 3 m's, and here we have 3 m's. So we can pull out an m from here. That would be this one. We can pull out an m from here. That would be this one. And m times m is m squared. So the cube root of m to the 6th is m squared. Now let's look at this one, the cube root of y to the 5th. You will notice that y to the 5th is not a perfect cube. So that's what we are looking for. We need 3, remember. So this means we have 5 y's. We have 3 here. So we can pull 1 out from under the radical. And these two, sorry, there's nothing we can do. They just have to stay there. So we pull 1 y out. We leave 2 in. And we end up with y times the cube root of y times y, which is y squared, for our final answer. All right, let's look at this one. We'll look the long way at this. Don't forget, when we have both numbers and variables, we're looking for pairs of everything everywhere. First, we will do the numbers. 68. 68 is 2 times 34. 34 we can break down to 2 times 17. So here we end up with, well, we still have our x cubed, which of course is 3 x's. So when we're looking at just our numbers first, we see that we have a pair of 2's here. We can take a 2 out and leave the 17 in. Now we have our 3 x's. Again, we're looking for pairs. We have a pair of x's here. So we can take an x out. So we have 2x outside. And 17x has to just remain inside under the radical. So our final answer is 2x times the square root of 17x. Now, when we talk about fourth and fifth roots with letters, that gets pretty easy. Here we have the fourth root of x to the fifth. We're looking for 4 x's, so we've got 5. We need 4 to take 1 out. So we can take these 4 x's, pull 1 out from under the radical. That means there is 1 left inside. So the answer for this one is x times the fourth root of x. Looking at this one, it's the fifth root of n to the 8th, m to the 5th. Well, let's see what we have here. We have 8 n's, so we can take 5 of them. It takes 5 of them to get 1 out, so we can take 1 out. We have 5 m's, which means we can take an m out. So we end up with n times m times the fifth root of n to the third, because these 3 n's just have to stay inside. Moving along. It's your turn. Look at these problems, give it your best shot, pause the video, and then check your answers when you're done. Pause now. Okay, here are your answers. And if we have 80 x squared y, we can break 80 down to 8 times 10, which is going to be 4 2's and a 5. So we can take 2 2's out, and we end up with 2 times 2, which is 4. We can take 1 x out, so we have 4x, and what's left is the 5 and the y. So 4x times the square root of 5y. Now we have this fraction, and we end up with 8. The cube root of 8 is 2 times 2 times 2, and we have 3 x's here. So the cube root of x cubed is x. So in our numerator, we have 2x. And then in our denominator, we end up with 2 times 2 times 2 and 2 times 2 times 2 for 128. So we can take out 2 2's, and we have 1, 2, 3, 4, 5, 6 x's, which means we can take 3 out here and 3 out here, and we end up with 2 x's outside. When we simplify this, we end up with 2x over 2 times 2 is 4, and 2 x's is 4x squared. So we end up with 2x over 4x squared. We are not done. We have to continue to simplify. 2 over 4 is 1/2. X over x squared is 1 over x, and 1 times 1, that just remains a 1. So our final answer is 1 over 2x. Now, the last one, it's the fourth root. We have 243b squared. Well, we need 4. And we've got a b squared, so it looks like there's nothing we're going to be able to do about that. When we look at our 243, we have 5 3's. We need 4 to take 1 out, so we could take 1 3 out, multiply it by the 5, end up with 15, and underneath we're left with 1 3 and 2 b's. We can't do anything about that, so our final answer is 15 times the fourth root of 3b squared. All right, hope that helps, and I'll see you in class.